Good morning. Can you hear me? All right. You guys can see me, right? No? Huh. Wonder why you can't see me. Let's see if I can fix that. Oh, I know why. uh, now you can see me. uh, I think, let me look here. I think pretty much everybody's here. So hopefully you had a nice 4 days, had a chance to catch up, and you can hear me, right? All right, good, 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 good. I'll get rid of that. A couple of things as we're going through this. If you need an opportunity just to have some one-on-one time with me, you can just send me a text or an email, and I will set that up for you. Okay, I've done it a couple of times already. You just let me know. It's not like I've been busy here. I mean, I can only clean so much, and I can only go for so many walks with Rosie, though she's expecting it like all the time now. So, and it's like cold and snowy outside right now as I look out the window. So, if you feel you need that at any time, that is fine and dandy. I'm going to put chat on here too to see if I can see anything. So, I am going to, you have kind of a free response that's due Thursday. That's correct, right? That you gave yourself 15 minutes. So what I'm going to do is I'm going to give you one Thursday again, because you know that one of them will be 25 minutes and the other one will be 15 minutes. So I'm going to give you a 25-minute one. Again, you can use your book, your notes. You just can't use each other. And if you can time yourself, and I'll put those instructions on Schoology with the attachment, and then I'll give you a week in which you have to find 25 minutes to be able to do that. I think what you'll see is rather than A, B, C, D, you'll go probably A, B, C, D, E, F. It'll be a 2-pager. And again, you can just put it on notebook paper, your work, and send it to me. But make sure you use a calculator, though not every single question you need a calculator. And I'm going to do some problems today that I think you may see um, on that 25 pointer or another 15 pointer. Okay. All right. Before I start, does anybody have any questions at all about anything that they've done? I've tried to get yesterday, I tried to get caught up on AP Classroom and do some grading and put those um, scores on there. So hopefully you had a chance to see that. Okay. We are all silent. You guys love being silent. For a group of people that love to talk to each other, you do not like talking to me. Okay. Well, all right. I will. It just gets a little freaky on my part when here's the problem. And what I'm going to do this week is probably do two, because today is Tuesday and I have to remember it's Tuesday. I don't know if you've gotten to the part in your life where you really don't know what day of the week it is unless somebody tells you that. So I'm sure I'm thinking it's Monday, and maybe tomorrow I'll think it's Thursday. Um, so again, Friday will be pretty open if you just want to ask me questions. So I'm going to give you a problem today and a problem um, tomorrow's Wednesday, and probably another problem. And so again, I put this on Schoology, and it's from last year's questions. And I put it on Schoology, and the rubric is also in Schoology. you found the rubric, right, of the question that was the free response that was due last Thursday, correct? Everybody saw that rubric? Okay. And then did you see my corrections that I emailed to you through your school account? Okay. All right. So here's the problem. And I looked at this because, oops, you see nothing. You see nothing at all. Okay, where am I going to be here? Okay, share screen. Now you see something, correct? And so here's the problem. What's difficult about this one is it's a graph and they don't necessarily give you a function. And this was from 2019. It's a no calculator one, and on the one May 12th, you'll be able to use a calculator, but you get a lot of questions where calculator is not helpful, even on the calculator portion. So that's why I chose this one. And you have F, and it tells you it's continuous, and it's defined on this closed interval. And when you look up here, they don't start at -6, they start at -2, which is kind of poopy on their part. And the figure above shows a portion of the graph of F consisting of 2 line segments. So here's one of them. Here's one of them. And then a quarter of a circle. So this is supposed to be a quarter of the circle centered around 5, 3. So the center is right here. And it is known that the point 3, 3 minus the square root of 5 is on the graph of F. So this point right here, this point right here is 3, 3 minus the square root of 5 on F. That's that point. And we'll find out where that comes into. Now, whenever I see a problem like this on the AP exam where I have line segments that kind of form triangles, and then they tell me this is a quarter of a circle, I'm probably going to have to do some geometry to figure out the area underneath the curve. So a lot of times what you'll see me do is partition this graph into these kind of pieces. So I have a triangle right here. I have a triangle right here. I have this little itty bitty triangle. I have a triangle right here. And then I have this portion right here. So I kind of lightly shade it because I know a definite integral computes the area under the curve. And I've been kind of lax in saying that. Really what I'm saying is it computes the area from the curve to the x-axis, 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 from the curve to the x-axis. Before I even look at any problems, I know the area here is different than the area here. Or what I mean by this is the area in one direction, this is the area in the opposite direction. Here's an area in one direction, here's an area in the same direction. And so those are kind of the things I think about before I get to the problems. And so the first question says, it says, if the area underneath the curve from -6 to 5, now remember, I don't have a -6 over here. I just have a -2. If the area from a -6 to 5 of f of x, the area underneath that curve, the net area under that curve is equal to 7, find the value of this -6 to -2 that you don't see. Show the work that leads to the answer. So I'm going to ask somebody. Lillian, are you there?
Yeah.
Okay, do you have any idea where to start this? You're trying to figure out this little portion, the area to the left of this -2, correct? You don't even know what it looks like. You're told this whole area from that -6 to 5, the area underneath the curves, is equal to 7.
Wouldn't you find the integral from -2 to 5 and then do subtract that from the integral from -6 to 5?
Yeah, that's really, really good. So I'm going to write it just like this. I'm going to say, okay, we have an area from a -6 to a -2 of f of x dx is plus from -2 to 5 of f of x dx equals the area from a -6 to 5 of f of x dx. And I'm told that this is 7. And so this is me being a teacher, Lillian, okay? Here's a -6 to a -2 f of x dx plus, and so this means a -6 to a -2, and I'm going to lift this up, of f of x dx is equal to 7 minus a -2 of f of, 5 f of x dx. And so Lillian, is that what you were kind of saying?
Yeah.
Okay, so how would you propose that we go about, this is what we're trying to find out. How would you propose in figuring this out?
We could just find the area of all the triangles on the graph and then add them up.
Correct. Okay. Musab, are you there?
Yeah.
Okay. The area of this triangle right here.
1/2.
It's one this way, one this way. It's a half. Yep, looks good. Then Musab, would you say this one is what?
Another half.
Another half, but it's a half in the other direction, correct?
Yeah.
So can I write a -1/2 there?
Yeah.
Okay, so now these add up to 0. Would you agree?
Yeah.
In terms of with my walk with Rosie, it means I walked in one direction this way and then walked in the other direction, correct?
Yeah.
Morgan,
Yeah,
how are you?
I'm doing good. How are you?
Good. Do you like to get off stress? Do you dance?
I mean, not so much right now, but
You know, I
yeah.
started dancing. I might throw out a video just to the class, just to show you dancing.
Okay.
Yeah, to Bill Withers. Do you think that just would be weird or would it make people smile? What do you think?
I think it depends on the person.
Okay. Would it make you smile or would you just think it's weird?
No, I think it's funny.
Okay. All right. So you see this triangle right here?
Yeah,
Yeah, it's kind of a pain, isn't it?
a little bit, yeah.
Yeah. So we know it's negative. Oh, yeah, we know it's negative, correct?
Yeah.
And we know this is 1, correct?
Yep.
How do you propose we figure out what that spot is?
It looks like it's 1/2.
Yeah, it does. It does. You might be correct there. Let's see if we can, uh, let's see if that makes sense. Can you help me figure out the slope of this line?
Is it 1?
Well, it's how far I'd go up, right? I'd go from here, I'd go up 2 and 1 over, correct?
Oh, yeah.
2 and 1 over. So what do you think it is? You think it's 1?
2.
Yeah, it's 2. And so because if it was 1, it'd probably head over to this one, right?
Yeah. Yeah.
So if I head up 2 and 1 over, to keep that slope up correct, I'd have to go up 1 and then how much over?
Wait, what?
Okay, so if I have a slope of 2, right? I went up 2
Yeah.
and over 1, correct? That gives me 2 over 1.
Yeah.
What if I go up 1? Then I'd have to go over how much to have that slope of 2? I'll give you another hint. 1, 2, 3, 4, right? And then over 1, 2. 4
You
over,
just glitched on that.
pardon? I did what?
The computer's just glitching a little bit right now.
Oh, okay. Are you okay now?
Yeah, I think my internet's fine now.
Okay. So no, you know how I go up 2 and then I went over 1? Here I would go up 1, 2, 3, 4 and over 2. So
Mhm.
this going over is half as much as going up. Would you agree?
Yeah.
So if I go up 1, this has to be a what?
A 1/2?
1
No.
half. So you're correct. So that this distance right here is a half, correct? Right? From 0 to a half, correct? It's got a distance of a half. Because we're trying to figure out the area of this triangle.
You froze.
Oh, did I freeze again?
Yeah, my internet's not
Okay.
doing great.
Okay. I'm going to move on to somebody else. Ooh, it says right now I'm getting
sorry.
something that says my internet's unstable.
Yeah, that's what mine's doing.
Okay. All righty. Landry, am I frozen to you? Maybe Landry's not hearing me. Allison Stiegel, am I frozen to you?
No, you're good.
Okay. So what do you think this area here is here, Allison Stiegel?
1/4.
1/4. But it's below, correct?
Yeah, so it's a negative 1/4.
Okay. Okay, what about this triangle here, Allison? It's up 1, 2, 3, correct?
Is it 2 and 1/4?
Is it 2 and 1/4? Wow, it might be. How'd you get 2 and 1/4?
Well, I don't know. I just kind of pieced it together.
Oh, you said this is a fourth?
Yeah,
And you said this is a fourth?
yeah,
And that's a half?
yeah.
And that this would be 1.5?
You're frozen now, so I don't know what you're pointing at.
Oh, gee whiz, I'm frozen. I can see myself frozen. This is getting frustrating. All right, how can I get myself unfrozen here? Yeah, my whole computer's frozen. Allison, can you hear me?
Yeah, I can hear you.
Okay, I am going to reboot.
Okay.
So I might have to start the meeting all over again. We're going to give that a go, okay?
Okay.
Because me being frozen is not a good thing.
Yeah, that's pretty bad.
Yeah, all righty. So that's what I'm going to do. All righty?